Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, today we've got a couple other slabtop computers, this time with NEC branding, but in fact they're made by Kyocera, just like the Olivetti we looked at a few weeks ago, and the TRS-80 Model 100 and 102. This PC-8300 was sent in by somebody, and I believe it has a power supply problem. And this is its younger brother, the 8201A. This I got in quite a while ago, and I haven't tried it yet. So I don't know if it works or not. These are very similar, so I thought we'd first start by taking a look at how they're similar and how they're different. Let's get right to it. Here are just a few of the circuit boards I've had made recently by PCB, who is nice enough to sponsor this video. So whether you need a few boards or a lot of boards, check out PCB. Jump on over to the PCB website and get your instant quote on standard circuit boards, advanced, flex. They even do assembly, and you can get stencils made. For your next project, check out PCB. Here we've got the back of the two machines, and you can see that they're pretty much identical with a little different paint job. Now, all of these originally came with covers over all these ports, and I've popped a few off so you can see the various things. And if we start from the left-hand side here, we have the cassette port, printer, RS-232, barcode. This one's labeled here SiO2. It's labeled phone down here. This is labeled FDD here, which I assume stands for floppy disk drive. And this is labeled SiO1, which I'm assuming these are inferring a serial I/O. Reset, memory protect, and a DC 8.5 volt input. Now it's interesting, these take 8.5 volt center negative. The other Kyocera made machines took a 6 volt input. Again, on the left hand side of the machine, here they are nearly identical. They both have this little flappy thing here, which is a cartridge port. Unfortunately, I don't have any cartridges to plug in there. Front of the machine, there's nothing there. You can see this 8201A has some wear along here. And this looks like it was rubbed up against something continuously, and it's worn the paint off. And on the right hand side of the machine, we have the on-off contrast. That's the same on both. And you can see this 8201A here on top is missing something. That is the battery cassette. The batteries go in little cassettes like this, so you can pop the whole thing in easily. And you can either put 9 CADs or regular AA batteries in here. And there was a resistor on the PCB that's in here that you can change, so you tell the computer what type of batteries that you have in there. And if we have a look from the top here, we can see that other than a slight coloring difference on the keys and the bezels, the keyboards are exactly the same. If we look at both units side by side from the bottom, we see a different story, and we can start seeing where the differences sneak in. This is the 8201A here. This is the 8300. You notice on the 8201A that we have RAM modules, which are just like we would find on a Model 100, etc. We have an option ROM, and we have the normal basic ROM. And while we have the option ROM and normal basic ROM socket here, or system ROM, I guess would be a better explanation for that, we've just got a cover here where the optional RAM would go, so this thing must come loaded with a bunch of RAM. Also on the 8300, there is a big hole here that we don't have here, so let's get a closer look inside of that big hole. And here we can see inside that big hole on the back of the 8300. Of course, I've got the plastic cover off of there, but you can see there is an edge connector right here. So evidently there was some type of option that plugged in here, perhaps a RAM or some other feature like that, or maybe some type of expansion. I haven't read about that in the manual at this point. So now that we know what the similarities and differences are on the outside, what do you say we pop the covers and take a look at the inside? Well, like our other Kyocera manufactured machines, it looks like we've got a screw in each corner here. So we'll go ahead and pop these guys out. Okay, now I don't know what the interaction of this battery cassette with the innards of this is. So I'm going to go ahead and pull the cassette out. I will presume that it's going to come apart very similar to the other machines. Like so. Yeah, that's almost got it. There's definitely a catch there. And yeah, opens up like a book. Very Model 100-esque. Now there's some reflections causing issues with the camera, but first thing I notice, we've got some deteriorating sticky foam in here, which we'll have to clean off there. That stuff can also turn conductive. And we've got a couple keyboard cables. That also looks familiar. Here is a grounding wire. We've got other grounding wires coming off this shield here to various places on the board. And we have our LCD cable, and again, this LCD is very Model 100-esque. So this isn't completely unfamiliar. So I think the next stage of attack here is I will take a couple still photos of how all the cables and everything are arranged. And then we'll pull off all these various ground wires and unplug the cables from the top. Okay, I snapped a couple pictures. I marked the connectors. I always like doing that. Just a little mark here on this ribbon. It's probably self-evident where it goes back on, but it never hurts to leave yourself a hint. Can't quite see that. This screw right here, we need to get that guy loose. And we'll just go ahead and put this screw back in the same hole and save it for later. Okay, I also need to take this guy loose. And again, if we put him back in the hole, don't have to keep track of it. Okay, those are loose, those are loose. And this ribbon here just slips up like that. It's got a little release there, and then you pop it up. Okay. That will allow us to detach our keyboard. Okay, now we just have the bottom half to worry about. I've got this shield loose. If we look inside here, looks like these might be our RAM chips. They went to surface mount. We have our processor, our I/O chip, our serial chip, a smaller memory battery, but it looks like you can put the normal footprint memory battery in there. This here is the power supply board. They put that on a separate board right above the battery cassette. So that's probably what's of most interest to us at this point. I do think I'm going to try to get this RF shield out of here. So probably means taking this cover up as well, I would suspect. Okay, it looks like this little bracket comes off on its own. Yeah. A little speaker that's on it unplugs off of there eventually. Oh, I see the spring for this little flap is on the metal piece. Okay, we've got a screw here. And perhaps we're going to have to get the power supply out of there first. Same type of screw. Yeah, that comes out with the power socket attached. Kind of sneak that out from under that RF shield. Oh yeah, there's more nasty black foamy stuff on the bottom there, and there's little bits of it all over the board. Yeah, we're gonna have to clean that off of there and find a substitute. That's there so the shield isn't banging on the bottom of the board, eating through the shield and causing shorts on the board. The screws come loose from the bottom of the 8201A, just like the 8300. And the case opens like a book, just like the 8300. And while the screen and the keyboard look very, very similar, you notice that the rest of our board here looks very different. This is more like a Model 100 construction, all through hole, using cables for the keyboard, power supply, a regular ribbon cable for the LCD, that type of thing. We've got a couple of the Model 100 type RAM modules built in. Remember, on the bottom of the board we had all the RAM modules mounted there. And we've got a lot of discrete glue logic everywhere. Here we have our 8085 processor. This is the 81C55. That is the parallel I/O chip. And this is the serial chip. So let's get these two boards, the 8201A and 8300, side by side so we can compare them better. So here we have our two boards side by side, and you can see the similarities and the differences. The ideas are pretty much the same. We've got our power supply mounted up here, our big chips, the processor and parallel I/O and stuff. The big differences on here is the 8300 has 3 custom gate array chips that replace all of this discrete logic all over the board. And it has surface mount RAM chips mounted here, whereas on the 8201 we've got the 2 RAM modules soldered in from the top, and from the bottom we've got sockets for several other RAM modules. Memory backup batteries in the same place. We still have this type of riser board here for the printer connector. On this one it is individual wires that plugs in, and this is a stiff ribbon cable that is soldered on both sides. So the same idea. This is definitely an updated board with a little more features added, cost reduced with the gate array chips, that type of thing. With both we can see the original TRS-80 Model 100 heritage, and the same types of ideas carried through on a lot of the same parts too. Well, I say we go ahead and we take a look at the problem on this board, the 8300, and if we have time to it, we'll get back to the 8201A. So doing a visual inspection of the power supply area, I noticed a few things. Well, this area here and this area here look like it might have been corroded, but these are actually the voltage test points. That just means they've been probed on, so that's probably not a problem. If we get around to this big capacitor here, notice this section of the board doesn't look too good, and I thought maybe it had leaked, but I think somebody's tried replacing that at one time. On the bottom, the solder joints for that big cap look rather iffy. They don't look like any of the other joints. So I'm suspecting maybe somebody's replaced this. That could very well be a cold solder joint, and that could be the whole problem. So I think first we'll try to power it on and see if we get the same symptoms. And then we'll pull that cap out and test it to make sure it's okay. And if it's fine, we'll pop it back in, do a good soldering job on it, and see if we get lucky and that takes care of it. Okay, I've got the external wall wart plugged in. I propped the power supply board up on an empty battery cassette. That way it's not flopping around in the breeze. I'll go ahead and kick this guy on now. I'm going to put my black lead on ground, red lead on VB, which is the voltage on the battery, which is the memory battery down here. And he's at 3 volts, which is about right. And if we go VDD, that should be 5 volts. We're getting 1.3, which isn't right. And I don't see the VEE test point, which is the minus 5 volts. No doubt there's one on here somewhere, but I am not seeing it. But it's kind of curious that we don't have the 5 volts. Now what happens if I measure across this big bulk capacitor? We've got 5.5 volts there, which is probably coming from our external supply. So I would say our power supply is not starting up, but this transformer here, where my finger's touching, is noticeably warm. So something's happening. I was using the voltmeter to test the path of the voltage from the power supply, where it goes through the memory battery switch and then through the main switch and back to the power supply to be switched and turned into 5 volts and minus 5 volts. So it was getting from the power supply and out and back in, but the 5 volt output was really, really low, and I happened to touch the transformer and that was quite warm. And while kind of looking at the board and flipping over, I touched this area of the board and it was also warm. And I narrowed that down to this chip right here. This is some sort of custom gate array. In fact, all 3 of these chips are. These replace several different discrete logic chips on the 8201. You know, like AND gates and OR gates and that type of thing. And I noticed that this chip was going up to this expansion port here, and all the pins on that expansion port are covered in that degrading sticky foam, and it doesn't seem to be conductive, but it can turn conductive after a while, and there's some other flakes of it on the board. So I think the first thing we'll do is go ahead and clean that off of there just to eliminate that as a possibility. If we look at the cover here, we can see this is the area, or that would have been making contact where that foam is. And if those pins poked all the way through the foam and got through the plastic sheet and into the aluminum of this shield, it may have shorted out. So we'll have to clean the foam off of here too and look for any damage through this plastic coating. I'm not sure the best way to go about cleaning this up, but I am going to try some alcohol and a toothbrush. Oh, well, that was a little quicker than I thought it would be. Just kind of dissolved the foam straight away. There's another little flake of stuff up here. Oh, you might notice this zip tie here. I zip tied the printer connection on there since we didn't have the screw through there anymore, so it wasn't bouncing around, potentially creating a problem. And looking at the top, I don't see any foam bits on the top, but there may be some that's gotten in some nook and cranny somewhere. See if we can't look at that, the shield from the bottom cover, to see if it looks like the pins work their way through it. Sometimes here's what it takes when you're trying to figure something out and you don't have really good schematics or information. I mean, I've got the schematic for the 8201, which is similar, but not exactly the same. For the power supply here, the pinout is similar to the 8201, which I do have kind of a schematic for, which I don't think is exactly right. Or maybe it's just a difference with the 8300. At any rate, all the power output is through this first ribbon connector. And the power in, which goes down through the switches and back up to the power supply, goes through this connector. So after pulling the power supply off and jumping the input and output pins, I was able to see I was getting 5 volts and minus 5 volts out of this guy. But when I plug it into the board, it was loading down the power supply, and there was only about 1 volt. So I thought, well, let's go ahead and power the board with the 5 volts from my bench power supply, and we can set the current limiting on that and see if there's a problem. Well, I did that, but the problem is this guy wasn't running. It was drawing about 20 milliamps and not doing anything else. And come to find out that the reset signal is coming from this power supply board down to the processor here and everything. So I had to rig up some jumper wires and stuff to pull the reset line input to the processor low so it'll run. And now it's doing stuff. I don't think it's doing the right stuff, but the address lines are addressing and the data lines are dataing. And the current draws about 54 milliamps, which is about right with no display hooked up. And this chip here that I thought was getting hot, yeah, it doesn't seem so much anymore. I don't know if cleaning this gook off of here did that or what. Oh, the other thing I did to the power supply to get it to turn on was pull transistor T12, which is this little guy. And this is very similar to the Model 100. There's a transistor here which is responsible for the auto power off circuitry. It hooks up into here and stops it from oscillating. So I pulled that. That way you can force the power supply to stay on. And I am getting the power output out of the power supply, both 5 volts and minus 5 volts now. But for some reason, it's not able to supply the 50 milliamps for this board, which seems strange. I might try next just jumping the 5 volts from here down to the connector below to see if it's the 5 volts is okay. Maybe the minus 5 volts is an issue. Although I think the only thing the minus 5 volts goes to is the LCD. But we shall see. Some more experimenting is called for. Well, I did some more experiments before settling in on what the source of the problem was. You notice I've got both ribbon cables plugged in now. When I still had the DC output cable unplugged and DC coming into this board, I took a 100 ohm resistor and put it across the 5 volts, which will draw about 50 milliamps, and the 5 volts did just fine. So that made me think that the power supply itself was probably okay. It was perfectly capable of supplying the current that this board needs. There had to be another problem. And I spent some time perusing all these lovely schematics covering the power supply section and the rest of the computer, and realized that the entire reset circuitry is on the power supply, and it's a little simpler power supply than the 8201. It's missing U2. This meant that the processor wasn't running because the power supply was not providing the reset signal like it should. Which I thought, well, that points back to the power supply, but the power supply seems okay. And then I got reminded that on the Model 100 type computer and this type of computer, that there are some of the ICs that are actually powered from the memory backup battery. Specifically, everything involved in reset is powered by the memory battery, and that's needed so when the computer is turned on, the reset works properly every time. So I got to wondering, well, what if it's not being reset properly because there's a problem with the memory battery, even though when I measured it, remember toward the beginning of the video, it seemed to be about 3.2 volts. I measured it with power off, and it was dead, completely dead, about 0.4 volts. So I pulled the battery. Here it is. It was living right here. I pulled the battery, and lo and behold, everything works fine now. So a bad memory battery was the cause of the whole problem. Now, I don't know if the memory battery was loading down the power supply, or probably more likely it was preventing the power supply from providing the reset signal and starting up properly, and it was kind of in this quasi-started up state where the output voltage was too low. Now, why that made this chip and the transformer get warm, I don't know. I can't find any information about what this chip does other than see where the traces go here. So perhaps, you know, the power supply was really trying to supply 5 volts. It couldn't, you know, if this battery's bad, it's trying to charge the battery. It can't. Perhaps this chip was in some semi-started up state where it had some gates in an in-between state that was causing a short circuit. I don't know. So I will replace the backup battery with a new one. You can also fit the style that was in the M100. It's got double length pads here. And I also need to put back transistor 12 that I took out of the power supply. And then we should be back in shape. Of course, we'll need to put transistor T12 back in. And I also found this choke was a little loose, so we'll have to glue that back down as well. We'll go ahead and fit a new memory battery. This is slightly larger than the original, but they included extra holes for it, and we'll solder it in. So right now, if we measure the battery itself, and this is with the battery switch off, we have close to 3.2 volts. That's as it should be. And if I measure V battery on the power supply, I get 0 because our battery switch is off. Now if I turn the battery switch on, let's see what we get then. Yes, now we're seeing a little bit less than that at the power supply, which is correct. And if I plug in the external power supply, which you can see here, still got about the same there. I do not have VDD because we don't have the power switch on yet, which is down this way. You can't quite see it. I'll turn the power switch on now. And we've got 5 volts. And I forget, and this is VB, and now we have 5 volts there. That's the charging voltage for the battery. I forget what the minus 5 volts is. I think it's like pin 6 here. 1, 2, 3, 4, 5, 6. No. 5. Nope. 4. 3. Pin 3. Minus 5. Okay. Now, I suspect this thing is actually running. Let's go ahead and plug the LCD in so we can confirm that. Got the keyboard, or the LCD at least, plugged into the computer. I'm not bothering with the keyboard cables. We don't need those plugged in to see that it's operating. And I will rotate the LCD over now. And there we go. And we'll go ahead and kick this guy on and we'll see what happens. Haha. Despite the glare, we can see that. The LCD looks quite nice. So, I think what we need to do now is get our replacement black foam stuck on that RF shield and get that little toroid choke glued down on the power supply, and then we can get it all put back together. Excellent. Okay. I've tried to set up the camera manually here to keep it from wanting to darken out because of this shiny flap here. You'll notice I have installed some self-adhesive foam where the nasty black stuff used to be. This is a little harder rubber, foam rubber type material than the original, but I think it should work fine. And now we need to get our board plugged back in here. One thing I'm going to need to do though is remove that battery cassette. We can try to slip this guy in here like so. Some of the screws go through the shield, which we'll have to get lined up as we put the screws in there. Luckily, all of these screws are the same size. Stuck the screwdriver through the hole, positioned it, and then pushed down to hold it in place. I think we've got the right numbers of screws left now. And remember, this guy's got a spring on it. So make sure he's pushed up against the flap. Well, actually, there's 4 screws. It makes me curious what all sorts of cartridges were available for this thing back in the day. I don't know if you guys ever seen any. What were they for? Okay, so we've got all the screws started on this side, and we need to hook this ground wire up over here. I know this goes like this. I took some pictures of these cables, I think. Oh, you know what? They have different numbers of pins, so you can't get it wrong. How about that? I love it when they do things like that. Okay, so that is everything connected. And we can go ahead and fold the top back over. Get it popped back together. Then I'll put the 4 screws in on the bottom. Well, we have our PC-8300 all back together. We are running off of batteries now, not external power. Everything works great. LCD looks great. And I was even able to type in a little basic program, because you know you got to do that. And everything works fine. So I would call this repair a success, and it was a rather easy one, even though the symptoms were rather odd. This nice example of an 8300 will be on its way back to its owner, and I think we'll make another episode out of going through the 8201 so we can spend some more time with it. Well, I hope you've enjoyed this episode where we got to fix up this ailing PC-8300, and while it wasn't a complicated fix, the symptoms sure were odd. We also got to compare it inside and outside to its predecessor, the 8201A, and we could see the lineage between the two, as well as the rest of Kyocera's line back to the TRS-80 Model 100. In a future episode, we'll take a little closer look at our 8201A here, because we didn't have time today, and we'll see if we can get it fixed up as well. I would like to take a moment and say thanks to everyone who helps support the Hey Birt channel through Patreon and other means. If you'd like to find out more about becoming a contributing member, well, just look down in the description below and there are some links there. If you're a subscriber, thank you. I really appreciate it. It helps out a lot, and it's very encouraging to watch that subscriber count grow. And if you're not a subscriber, well, it's free and it's painless. If you look down below, you'll see a rectangular box that says subscribe in there. Well, it does what you think. You click on it and you'll be subscribed to the channel. And then if you click on that little bell-shaped icon, well, YouTube will let you know just as soon as I post a new video. That way you'll get to be one of the first people to watch it. If you have any questions or comments, well, leave them in the comments section down below. I'd love to hear from you. And until next time, bye.